polynomial, you still are going to distribute the first polynomial into the second polynomial. But the problem is that it's a polynomial. So like maybe it's a binomial that comes first. And so you double distribute because a binomial has two terms. But maybe it's a trinomial. That's your first one. So you'd have to distribute 3. You'd have to triple distribute. Each 3, right? Each term gets distributed to the other terms of the second polynomial. So it can get really long, right? It can get pretty messy because you can end up with this really gigantic problem. For example, if I started with 2x minus 5 times x squared plus 8x minus 6, right? I have a binomial times a trinomial. We cannot FOIL. Foiling only works for a binomial times a binomial. So I have to double distribute. So I'm going to color code this. It's going to get a little dicey because I might run out of colors. But I'm going to take the 2x and I'm going to multiply it by the x squared. And 2x times x squared is 2x to the third. And then I'm going to go back to the 2x, and I'm going to multiply it by positive 8x. And 2x times positive 18x is 16x, positive. And then I'm going to go back, and I'm going to take the 2x, and I'm going to multiply it. Oh, x squared, I forgot the squared. Sorry. And I go back and get the 2x, and I take it to the negative 6 to get negative 12x. So I distributed the first term 3 times. And now I go and I take the second term, negative 5 times x squared is negative 5x squared. And then I take the negative 5 and I go to the 8x, which is negative 40x. Ooh, that's hard to see. Negative 40x. And then I go back, pink, to the negative 5, and I go to the negative 6 to get positive 30. So it creates quite a long chain, because then on top of that chain, I have to go in and see what gets combined, because there are going to be terms that should be combined. So x to the third, nothing else, so 2x to the third. And then I have an x squared and another x squared, so that's plus 11x squared. And then I have an x and an x, which is negative 52x, and then plus 30. I'm going to get the correct answer. I just have quite a bit written down. And sometimes, not all the time, but some of us are not horizontal thinkers, right? Having it horizontally sometimes is a little more challenging. It's still doable. It works. And if this was a trinomial here, if there was another term, right, I just would have done it, distributed that again. Like if it was a 4 term, right? You just distribute however many are in that first polynomial, each one gets distributed to each term in the other polynomial. So this is if this is your go-to, stick with it. The grid method just kind of organizes the information a little bit more for you. For example, you make a grid that matches your polynomials. So I'm going to make it a big one. I'm going to do 4x squared plus 3x minus 1. And I'm going to do x squared minus 3x plus 7. It's a trinomial times a trinomial. Now, I could 100% take this and distribute 3 times, take this term and distribute 3 times, take this term and distribute 3 times. That works. I also know that this polynomial is a trinomial, 3, and this is a trinomial, 3. So I'm going to make a grid that is 3 by 3. And I'm going to put one of my polynomials on top and one of them on bottom. It doesn't matter which one goes where. I'm going to put the first one on top. Positive 3x minus 1. And then going down, I'm going to do x squared minus 3x plus 7. And then I can fill in my grid through multiplication. These two get multiplied and the answer goes in this box. So 4x squared times x squared is 4x to the 4th, which is the same thing as taking this and distributing it here. There's my answer. And then I'm going to take it, I'm going to go back. 4x squared times negative 3x, negative 12x to the 3rd. 4x squared times 7 is 28x squared. This is a different way of organizing. Instead of putting it all in a long line, I'm making a grid out of it. And I'll show you why in a second. Then I go back to my middle term and I'm going to distribute that. 3x times x squared is 3x to the 3rd. 3x times negative 3x is negative 9x squared. 3x times 7 is 21x. Then I have negative 1 times x squared is negative x squared. If you want the 1 in there, that's fine. Negative 1 times negative 3x is positive 3x. And negative 1 times 7 is negative 7. And here's why the grid is helpful, especially to people who need some organization in their life. 95% of the time, your diagonals are the like terms that get combined.
What time is it when they're not?
When it's not is because like this has an extra variable on it. You know, like if this was AB, right? If it didn't follow a pattern. So when I write my solution, I have 4x to the 4th minus 9x to the 3rd, because these are like terms. Plus 18x squared plus 24x minus 7. And again, you get the same answer as you do up here. It's just organized in a different manner.
Which one's faster?
It all depends on just how it works for you. Like, Taylor's probably going to want to use the grid
Because she writes so
so big. she's going to need 18 pieces of paper lined up.
I don't think she'll be
Need
able to.
another 3 desks.
Right? But it's just a different organizational method.
Oh.
It's all however you want to do it. So I'll show you again. Let's do one here. And I'm not going to grid it if you, decide that you're not still unsure about this whole grid method. I'll show you just a way of organizing.
Look what I found.
Billy. Thank you. Focus.
I wasn't even listening to music. Look, nothing in my ears.
It's fine. Focus. All right, so if I was going to distribute, and I'm going to do this just in 3 colors of the distribution, you can make the grid and it works. It's a little more condensed. It makes things a little bit nicer to look at. Another organizational tactic, your choice. If I'm distributing, right, I'm going to distribute this guy 3 times. Yes? 3x squared times negative 4x squared is negative 12x to the 4th. 3x squared times 2x squared, or 2x, sorry, no squared, is 6x to the 3rd. And 3x squared times negative 6 is negative 18x squared. Yes? Okay. Then I go to my second term, and I'm going to distribute it 3 times. Negative 1x times negative 4x squared is positive 4x to the 3rd, correct? And I'm going to write that underneath my other 4x to the 3rd. I'm going to stack them. I can do that. And then I'm going to go back and do negative 1x squared times 2x. I keep saying squared. Negative 1x times 2x, which is negative 2x squared. And I'm going to put it underneath this one. Negative 2x squared. And then negative 1x times negative 6 is positive 6x.
Wow.
Bless you.
Wow.
Then I'm going to go back and let's do orange. 11 times negative 4x squared is negative 44x squared. And 11 times 2x is positive 22x. And 11 times negative 6 is negative 66. So here's another way of stacking it. Instead of writing it all in one big line, I could, every time I get something that already matches, that requires you having to kind of pay attention a little bit of what term you already have written down.
I know you got 2, 1, 0, 4, 3, 2.
But it's still vertical. Negative 12x to the 4th plus 10x to the 3rd minus 24x squared plus 28x minus 66. Right?
Divided by 2.
Miss Long.
Oh, yep, that's a 20, that's a 4, not just a 4, it's a 44. 64x squared.
Miss Long. If you were to stack them up together just like a regular thing, you just do like the grid way because they're diagonal. If they weren't like moved over one.
Yeah. Yeah, this could go underneath here, and this could go under here, and then it'd be diagonal. Okay, so let's try.
I like the grid, honestly.
One of the problems that messes kids up are problems like this that look really easy. X minus 1 to the third.
There's 3.
But remember, it is not as simple as x to the third minus 1. Because you take this and distribute. That's not right. Because x minus 1 to the third really means x minus 1, x minus 1, and x minus 1. And we cannot do 3 at a time. You have to do 2 problems. You have to do this problem first and get an answer. Then you take that answer and multiply it by the third binomial. So for those of you that like the grid, I'm going to show you how to grid a binomial and a binomial. You have to draw that grid. You have to draw the rectangle, which, you know, it's a 2 by 2, so it's not terribly taxing. And x minus 1 and x minus 1. So this is my first problem. X times x is x squared. X times negative 1 is negative 1x. X times negative 1 is negative 1x. And negative 1 times negative 1 is positive 1. My diagonals get combined. So the answer is x squared minus 2x plus 1. X squared minus 2x plus 1. I have to do the first 2 together. Now I take this answer and I multiply it by x minus 1. And it's your choice. You could make a grid, or you could double distribute and write it out. It's your choice. It just kind of depends on what works best for you. If I did a grid, oops, uh-oh. If I did a grid, don't close your eyes while making the grid.
Why'd you close your eyes?
I didn't. I was just being silly. It looked like I did. Still not great. X squared times x is x to the third. X squared times negative 1 is negative 1x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 is 2x. 1 times x is 1x. 1 times negative 1 is negative 1. And then my diagonals are my combines. X to the third minus 3x squared plus 3x minus 1. It's your choice of which organizational method you prefer. It does not have to be a grid. You can write it all out. You can write it all in a horizontal line. You can stack it like this. The trick is going to be finding a way to make sure that you get all of the like terms combined.